Assalamu alaikum friends, in this video today we will discuss about that PLC data types and how to addressing in the PLC. Because of that, all lectures first of all we have to be complete understand about the that memory addressing and PLC data types. Because of some some lectures inside, I think so it's hard to understand all students. So today we will discuss about this one, and we will create the here in Microsoft Excel, and we will make it here one also folder in documents or desktop. We will can create name PLC DATA data TYPES data types. PLC data types. Okay, first of all we will make it here heading. We will make it heading here to this area, make it manual, and we will make it little bigger, better as 20, 26. No problem. PLC data will make using PLC data data types and addressing AWD data types and addressing. And here next first of all we will start from here. For example, first we have to be understand bit is what yani in PLC when using we will start first is coming bit, BIT bit. Bit is the what's the function of bit? Bit have only two inputs can be we say 0 or 1. Bit have two things, 0 or 1. And secondly, when we use, one second I complete. Bit inside using only 0 and 1, and when we are using two bits, two bits, in 2 bits what thing using, because of 1 bit is 0 and 1 and 2 bits inside have coming 0 equals 0 0, and then 1 equals 0 1, and next 2 equals 1 0 and 3 equals 1 1. So how it's working? Yani 0 equals 1 in this language, PLC language, when using that numbers 0 and 1 bit yani only you can use 0 or 1 means on or off, also you can condition, and inside the PLC language also bit is called yani boolean data, and 2 bits if using after this 2-bit combination. This is how it's coming. I will tell you here it little the formula of this in this how coming 0 equals 0 0 and 1 equals 0 0 1 and 2 equals 0. When we using 0 0 we called 0, and when using 0 1 we called 1, and when 1 0 we used and we think 2, and 1 1 when we used we think 3. Yani this is the language inside using, and how it's coming I explain to you here. This combination have same using one formula at here in the PLC. When using this calculation of this memory have one formula which we used 2 equals formula which we used, we make it here and symbol angle 2 to the power of n 2 to the, where is that symbol on this one, 2 to the power is equal the n minus, and secondly used formula 2 to the power of n equals minus 1. What means that n is a sim here we will type n means the number of bits, and you BES number of BITS bits. N means number of bits. And how this formula applies in the PLC? We will take here one calculator. Yani for example, think about this when 0 0 equals 0, 1 0 equals 1, and 1 0 equals 2, and 1 1 equals 3. That yani how much coming 2 bits? Yani this is 4, because of when 2 to the power of number of bits and after minus 1 from the data. For example, here is 8 bit. I will type it here. 8 bit are also can called byte. 8 bit or byte data is how can calculate. Yani here we will take calculator, and here we can use that. Yani for example, this 8-bit data you like to calculation 2 to the power of 8 equals 256, and 256 is what thing? 256. When this formula applied, after you see that 200 to 56 minus after 1, how much remains? 255. When you're using that 8-bit data, you have using that 256, that when you're using this formula, 256 bits are in the 8-bit data, and minus 1 when remains from this, as per this formula, after answer will be coming how much? 255. Yani means when you like to write or written any data inside the, when using 8-bit, you have total memory is used in the PLC 255, and 2 bits data you have to use be only 4 bytes. Yani 0 0 0 1 equals 0 1, 2 1 0 and 3 1 1, and inside bit only have 2 betas. That combinations, when you take the answer, you have to use this formula. One more example we can take here. For example, that 16-bit data, how much the 16-bit or 2 bytes also you can say, or 2 bytes, yani 2 BYTE, yes, 2 bytes, and also or also can be say word, word, because in 16-bit data are called 2 bytes, or you can see in the language word, this will be called 16-bit data. And how we calculate this also 16-bit data? One more time we will take the calculator and we will go to the here, 2 to the power of 16. For example, first we are calculating the 8-bit data, and our memory total bytes coming 255, and 16-bit data when we like to using, and 2 to the power and 16 and equal how much? 65,536 is answer. How much this answer coming? 65,000, sorry, 536. This is the original. And when we apply this formula, we have to be minus 1 when made. As per this formula, minus 1 is remaining 65,535 here written, right? 65,535. In 16-bit you can write 65,535. And also one more example we can take when we're using here, for example, 32-bit or also we can say 4 bytes, 4 bytes, or also you can say 2 word, or one more also you can say double word. Why I'm writing this data? Because of some areas when using inside the PLC, we're using when write the double word, we can write inside the D word after your data can be using in 32-bit range. Because of this range must be selected when you write the data. If you low range using after you are have a problem. In 32-bit data, how is our memory? Once more time we will go in the calculator, and here we can go into the 2 to the power n 32 and equals, you can see how much is 4, 294, 967 and 296. This data comes answer in 32-bit data. Here also we can think so paste. It's not possible, I think so. Double word 32-bit data, what we can use 404 billion or how much, very long yani this figures 94 967 and 296. This data you can use in 32-bit data, and when you minus it here 1 into 1, after answer will be how much, last figure yani 295. For example, I copy (96, 95). This also you can hear it move and can make it bigger this box and can see. This is only for showing the purpose of. In 32-bit data you can using this figure in this range anywhere when program when using this double word or two word, what range you can write inside the program, in this range you can run. Have also more data, 64-bit also have data same like any 32-bit data when we content, and after this answer is coming, this is the memory we can use in the PLC. More data also 64-bit data also you can here monitor same like 64-bit data. Many more data are inside the 64-bit. What reading coming when you go to the one more time, we will go in calculator, and 2 to the power n 64. How much this reading 64, and after your answer will be coming this memory same as per 1. How much this reading, you can see it 18446 744 073 after 709 551 616 and 616, and your answer when you make it the minus here 1 minus 1 after here will be 615. Data is very highest yani range. The very high range. Sorry, inside when we make it here same like any readings numbers. Three, 9, 500. No, this is wrong. We made. So, yani for example, leave it this one. And this is called 64-bit data 18, and last figures will be coming 615. Yani this is your same data. One more time, maybe we will make some wrong thing. I think so. 2 to the power n 64 equals this your figures coming 8446. Oh, sorry. 2 to the power n. Oh, sorry, how much we will write? I would like to write 64, and your this data is you're coming 446 and 744 073 709 5551 and 616. And when you make it minus, your answer will be coming 15. And this is your the data of a this writing something another thing. Don't know. Can leave it this one. 16-4-bit data. Now let's how we use this. I hope this you understand about this 32-bit data, 16-bit data, 8-bit data, and 2-bit data and bit. Bit also only use bit use can use only 0 and 1. If you 2 bits using, you have to use this 4 bytes. And if you 8-bit data when using, your memory will be take the 255 capacity, and 16-bit data when you're using, this figure will become, and when 32-bit is using data, and this figure can be used. And in this data, you in the PLC, double word also you can use, 2 word also you can say, 4 bytes also you can say, or 32-bit data also can say. Inside also 64-bit data and 8 bytes also you can say in the addressing. And this I will make this number also. For example, here you can understand complete after you save this data. This is how we use this memory addressing. This is in any 2-bit data when using, this will be value, and combinations how we can take out, and these combinations are with this formula we can check the all memory 8-bit data 16 or 32. Now next what we check how we use this bit in a memory. In bit when using inside the PLC called BOOL, we can type here BWL BOOL, and other name data we can use BYTE byte, and other data we will use unsigned unsigned, and next we can use in SINT signed, and other we can use unsigned or word also we can say unsigned or word we can say. We can merge this also. Unsigned or word. Unsigned or word. Here also no, it's okay, but this in center we will use. 1 second, sorry, this is we directly right unint, because of unsigned and signed data we write unint or uninteger or word, or int data or undint undint or d word, d word, or dint also real or low int long integer int. This is same like in data. When for example this is bool is a bit called bool called bit, and byte also you can say 8-bit data and unsigned SIGNED unsigned short integer T short integer or 8 bit or 8 bit. For example, we will start from here in bit 0 or 1. 0 or 1. Because of bool is only bit and of 0 can be used in 0 or 1. Same as in byte 8-bit data, we can use 0 to 255. 0 to 0 to 255 or 0 to 255 or minus 128 to plus 127. In byte, you can use the data inside the program 0 to 255 or minus 128 to plus 28. As per use this formula, this is in byte or 8-bit data, you can use 0 to 255 or minus 128 to plus 127. And inside unsigned short integer or 8-bit data, when you using, you can use the memory 0 to 255. And in short integer, this is unsigned, and inside the signed short integer is can called any signed short integer, short int integer or 8-bit or 8-bit. This data you can write minus 128 to 128 to 127 means any plus 2 plus 127. This is things for any formula, because we are using that names. We no need this one. We will cancel this one. This he thinks any some another. We can write it here minus 128 to minus 128 to plus 127. And he is using the formula, yani as per this. We no need this formula. How can this stop? I don't know, but it's okay. This any data we can know about minus 128 to plus 127. 127. That's we call right better, I think so. Oh, this is going to the direct going to the formula. Pick from drop down list. $127. خلاص. Same like as an integer or word. An integer or word are unsigned, or here I can unsigned int, or can say 16 bit or 16 bit. Unint or word. Unint or word in this data we can use how to 0 to 65,000 535. This data you can use in unint or word, you can say also, or unsigned integer or 16-bit data. When you like to use, you can use this value from 0 to 6,000 65,535. Inside the range you can use the data. And in integer, signed integer are 16-bit. Signed integer, GNED signed int integer are 16-bit. 16-bit. In this data, as per same, first minus 32,768 minus 768 to same 32,767. Same as per undint or dword data, when you're using, you can use same unsigned double integer, unsigned double integer, unsigned double int integer are called 32-bit. 32-bit. And this value you can use 0 to 294 670 95. This data you can use to, yani from 0 to that figure you can use that same like yani this data in the unsigned double integer or 32-bit data you can also say. And DINT also called D double integer, double O double integer or 32-bit. Also this same like as a minus yani 200, that value we not write it here, minus 32, sorry, minus 2147, which value last time we made in the DINT double integer. So I will write minus 2 14 45. 2 same plus 2 147 47 48 36 48, not 48, 47. And this data also you can use in the double integer 32-bit data. This figure has been used, you can use. And also in real, when you using the real means floating point number. Real means what name? LOAT, floating point number. But R can card 32-bit, 2-bit. And this value is coming into the points, yani 1 point, for example 175 494 35E dash 38 to minus 1.75 49 43 4 43 5 5E dash 38. Or also you can go in minus 3.4028 2347E plus 382 minus 1.175 49435E minus 30 bit. This data also you can use as per symbolic in floating point numbers. This is called real. And if you make in long integer or can called 64 bit. And this value also start from minus 9 double 2 3 series 72 036 036 036 854 double 7 5 8 0 8 2 8 2 8 2 plus 9 as per yani 223 372 036 854 double 7 5 808 807. Same this in long integer 64 bit data you can use in from minus 9 to this value from last 807, any from 8082 from 807. So that's same yani in boolean type called bit 0 or 1 you can use. He is asking for any formula, leave it. Yani this is bit inside 0 or 1 you can use in when using the byte 8-bit data and 0 to 255 or minus 128 to 127. Yani means this is more many datas also in the PLC, but when you using the datas in the PLC which like to be write in byte or 8-bit data, you can write the value only from 0 to 255. For example, if you any data like to type in 8-bit data, your range will be must be 0 to 255. Otherwise you if big data you like to yani from 255 up to this data yani for example 200 you like to write, you can write in this 8-bit data also. And also you can sign in unsigned short integer 8-bit data also you can write. If you like to 300 data you cannot write here in this unsigned 8-bit data. Here also you cannot write in byte 8-bit data. Also here in short integer 8-bit data also you cannot write, but in unsigned integer or 16-bit data also you can write. For example, if you like to write 6000 or 65,536 6 if you like to write, you cannot write in the unsigned integer 16-bit data inside this data registers. You cannot use this value. Yani up to your from 65,535. If more than this value you like to be write, you have to go, must be in unsigned double integer data, where you can say D word. Many of lectures inside we use that bool used, byte used, unsigned used, sign used, unsigned or word used, integer we used, and d integer d word also you can use this value. If more than this value, yani, you can write in this one. After also in double integer 32 bit, here you can write the in minus or plus value, can write in the d int data. After if you need in real, yani in points, yani if real data if you like to write in the PLC, you have to go in this floating point number, this values from. If more than this bigger value you like to write, you not real in the real, you have to be going long integer 64-bit data. Inshallah will be in next lectures. We will use this all values in the program. Already some values were used, but in learning purpose, I will show you how to write this all data inside the PLC. Must be watch complete videos, and also after you can understand. This is not writing, this is the in other system, but for learning we use this one. Also I will give you one more example inside the program. Yani for example, we go into the project view. This is open oval, one old our program. In this lecture only have discussing about this the PLC data types and memory addressing, how we use the memory address. This also I explain in 1 second. Delete. Delete. 1 minute, I will must be first explain to you. This data types are remaining. We have to use how to any memory bits we can use any. For example, we will start from here 0 and 1, 2, 3, 4, 5, 6 and 7. For example, in memory, from 0 to 7. Yani here for example from in this is the bit, yani for example 0, and in every byte here we write byte BYTE byte. Byte, for example, sorry, when in every byte have a 7 bits, yani 0 to 7, and here when we go to the down, yani in start from 0 in 0 byte, and 0 1 2 3 4 5 as per gone down, and this is the 0 bit, and inside the 8 bytes, yani 0 1 2 3 4 5 6 7 8. For example, 1 byte 0 से 1 byte 0 to 7 have 8 bits. For example, I will more write here than yani. This one also I will put 1 0 0, and that 1, that 2, that 3, that 4, that 5, that 6, that 7. Yeah, and here we will write this one, for example 0 byte, and this one is for number 1 byte. Each byte have a 0 to 7 8 bits, yani in memory addressing. Here also I will write to you how to use MEMORY memory in Siemens PLC. Memory, how we use in the PLC. You have to be must understand about the system. In each and every byte have a 7 bits. I write from here to there. It's a little wrong, but it's okay for understanding. And for example, this is the 0 byte when you using from 0 1 2. Here when you going down, same like any 2, sorry 2, here 3, here 4, here 5, here 6, here 7. Yani when you choosing the byte, you have to be go down look like, and when you using the bits, this seem like any bits. For example, this bit I will make it highlight in the colors after you can little understand. This one is also colors, it's okay. Yani each byte have a 0 to 7 8 bits. For example, and also this addressing, one more thing I tell you, that in memory addressing, how use the kind of memory. One is for M, yani when we will write here, for example M0 or M1 M2, when we're using the memory, internal memory, we have to giving that address same like 0. Also this 0 dot 0, 0 dot 0. Also this one M1.0, M2.0. Same like addressing, bytes are increasing to the downside, look like as any how much you using the memory in 3 types. M means M means memory, MEMORY, memory. And secondly, have I equal input, and Q equal output. How is addressing? If you like to using for M0.0, how you using? Yani from the first byte, that from 0 byte have to be using that one number bit. And for example, if you like to write M0.3, which number you using? From the byte address 0, and from this one by 0.3 you will be used. Yani this is same you make addressing in 0.3. And if you using for output addressing, input addressing, for example M1.0, if you like to use this from byte this one, and that one 0 is your address, first 1.0. And if you using in Q means output, that the symbol of Siemens have in output addressing Q 0.0 start from 0, first byte from 0 dot first bit 0. Same like as per increasing the data, yani for example M0.0 from started 0, M0.0, 0.1, M0.2, 3, 4, 5, 6, 7. But this will be when reading this concept M0.0, you have to be think about number 1, yani your address, and total will be 7, total will be 8, and when you giving the address you have to be start from M0.0. And same as per yani input addressing, when you making you have to go for I0.0. I0.0 is same like as a when you write it here I0.0, but first of I0.0, because the compulsory must be when you put the I0.0, you have to be the percentage sign, you have to be put must in the memory addressing. When you put I0.0 means yani your first bit of 0 and first byte and first bit you are using at I0.0. And if you using for Q0.0, also you have to be use first percentage, and also after Q0.0, this will be your first input in the PLC. As per same, if you when using that downside, yani when you have to be using in this Q 1.0, you are using the byte number 1 and memory addressing it 0. And also same as per this is increasing when you make data. For example, one more example I will give you. For example, M1.4, when you like to use, where you go, this is for example M1.4, when you using, which one would you choose? That byte number 1 and that bit number 4, this you will be using. And after, if you using too much any data, after this concept, how you can read in MB, for example 3, MB3, Same journey when using MB3, this one 3 you can use at this complete yani from 0 to 7 you to use this one 3 yani 1 2 and 3 yani from 3 to program. For example, that PLC tags and PLC data types. This also add new type it here. For example, I will use it here 1 bit. For example, this I use. Also, I make it here one name yani. For example, start I will put. Start I put that if this I have to be must be define the tag first because of this start here which memory address I like to use. This is all data you can see here. I start make it that one tag defined and that which memory I am like to using that local temporary memory also have a global memory, also have a global input, also have a global output. I'm using that global memory. For example, if your M0.0 is a blank, it is not used in the program, this automatically can be shows it here. And if you like to be change it here, you can it 0.1 also you can choose and also you can the define it. And you will define it this one and also here one memory we will use that for example this I will put it name motor 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 motor. If I put it this one another tag this one motor and this I have to be define this tag. For example, this memory which I am using yani this global memory is input or output which memory I am using I have to be select here. For example, I got this memory output global input output and it will showing now Q0.0 because that your Q0.0 is not used yani. If this is already used in your program that will be showed from the next yani. Also you can hit like to change it here. You can Q0.1 also you can use and also that we define. And now this your two tags are ready in this memory addressing. And after you can one more tag we also can make it here. For example, this data block sure tags user data type that default tag table. See here we make the all one tag this one we will make in input memory and one we make it for output memory and here it one more tag we can define it here. For example, analog we will make it here analog underscore 1 if I use that tag define and if I have a small value I can use in int or DINT. For example, DINT if I like to use I can use DINT. If I like to use double word also I can use double word. And if you have a small data you can use in MW0 or MB data or MD data. Which data you how much use your value that's depend on your data type yani. Which data type for example I use this D word data and also after you have to be define it here. That Q is asking which data you using. I using yani opener D data type and which data I am using for D word में MD10 for example I am using this MD10 and that Q identifier MD10 is my defined this that data register for this one analog and then click it OK. Now MD10 is data register I am using for this one memory addressing. So when I using here that for example I used my one instruction here in bit logic, this one, take it here. For example, I am using that timer TP on timer, this one, and I have to be using this data register, and also you can go that analog MD10, this data register is you're showing here. And here also you one more data register if you like to see the value from this one, and also you can use here MD series, your 10 already you using MD15, you can use it here. MD15. Also here we can that analog 10, and this data register I am used inside, and show the tag table, that tag 1 MD15. This tag 1 I have a name, and this if I like to rename the tag also I can change it here. Output value, out VELUE, this also you can define it here, and also you can go here your data registers came it here. And also if you using one more data register we can use here. Also you can stop push button, you can define stop push button. When you defined that, you have to be define the tag that you local memory, this is input or output, or which memory you can use I put use this one input memory. And here he says I0.0 is your internal memory. If you use in bool, this is have using in boolean. If you like to use this also, percent m 0.2 for example, I use this one. And yes, this tag also you can define in the program, and this program you will download to the PLC, and this will be worked as your download. Error found during completion. He says have one error. We have to be go back first, and we have to be check one error. What's the error? Analog 1 MD10 we used, and this is I used this something wrong, this one. And this if is close, consistent download, refresh. Software compiling completed with error. Different modules different between configured and target modules online. He says difference between configured and target modules online, which is your online module. He says that's have a difference showing, and we will go to this one. First save the project. What he says, difference between configured and target models online article number 6 years and offline firmware version 4.5, offline is 4.4 version. That's the problem with this. No changes. We will closing that project all. We will create the new project, no problem. And also add new device and go to the CPU, and which model you have to be check it here. That model I have CPU 15C DC relay, and this one article 14.5 4.0 we can put, no problem. In this program's main hobby, for example, first we download to the PLC this one blank, and after it will be refresh, start search, and then click load. Delete all and then click load. Because old everything data it will be closed. And then click finish. Now this is see our all complete is now ready. Now we will use it here. For example, this I will put start here, start, and make this tag, and I have to be define this tag. Right click on this one and go to the define tag, and here you have to be tell this one global memory, and this M0.0 is first bit is free, and automatically he will be stored this one, and M0.0 it will be stored. And secondly I will take that data, and here I will make the motor or motor, sorry, MOTOR motor. Thus I define this tag one, and I'll right click and define the tag, and go to the memory. You have to show an output, and first bit is output is free, not used, and this you can be designed, and Q0.0. And also if here I need one more output stop, stop, that when I defined, and that also I defined this one tag. For example, this I need in input memory. If I like to use that I0.0 is free, and that one I will use here. And also one more, if I need it here analog signal, for example, so I will go to my default tag table, that PLC, go to the tag tables, show all tags, and that my default tag table, and here I make it one more data, analog underscore 1, that data type, how much value I like to show it here. This one in int I need, DINT need, word need. If I have a small value I can use this one word, and also I have to be here defined this word. Now this is the identifier I have to be tell, this is Q or M. I have to be using MW0, This I am using this data register MW0, and one more tag I will take this one, output value, out VELUE, out value I use. This also I like to see in word, yani that's also it automatically takes the MW2. So here I used one my timer, for example timer I used it here, and that here I used this old q0.0 tag if I used, and here I use my data register, this one, uh, that default tag table MW0 that I used, analog 1, MW0, MW0, analog 1. I have to be check in default tag table what's the problem to this one. Analog value I am using that in word, I will using in D word, no problem, the D word, and this also I will MD0, okay, MD0, and this also I will use in D word, and MD2. Now this tag MD0 and this MD2, I will check the out value in the MD2 when my that Q0.0 will be when on, and my this data register will be, and my timer will be on, and I download this program to the PLC and then click load and make it simulation on. And this value when you'll have to see in display format in decimal. This also you can this display tag in make it in decimal. And for example this now MD format, this D word data he says the here you have to be put in decimal, you have to be go in decimal. And for example I make it here 3000. For example this is the 3000 hexa, not right. For example I use it here 2000, it will be no right. If I'll be use in decimal 55, sorry, that modify to 1, my that Q0 dot I0.0 is the stop condition, I will make it this on. Now Q0.0 is on, it will be running. For example here it will write this one 15 will be go to the 0. I have to be one more time. It will be download mistake. After this will be no download to the PLC. Modify to 1. Now Q0.0 will be on, and that timer that one more mistake. Let's input time it here 3 seconds for example. This will be go in that 3 seconds have to be one more time download. We need here one data register. This we will use our tag MD0. MD0 don't have. We go to the default tag table. This MD0. This we will use this one MD10. MD10 data register and MD20. MD20. MD10 and MD20, and this I download to the PLC. Then click load, because MD0 data register is C. We will define this one, modify default decimal, and here we will write in D word data decimal, we will write 20. See, it's 20. If I write it here, for example 200, it will be coming 512. Decimal, I will write it here 1000. It will be no right. See, in hexa decimal, if I write 900, it will be right. If I write it here 1000, will be write it 1000. 1000 means that 1 second. If I write it here 3000, it will be shown as 3 seconds. See, it executes after 3 seconds, this one on. So this is C, yani MD10 is the serial of data registers. Hmm. 16-bit data. So integer. unsigned integer. For example, see, if we use this one data, I will make it this one offline first to after this use understand. This one data MD10. Now we will go to the default tag table. This analog, this I used it here. dboard. Dboard means unsigned double integer data 32-bit. And if I used unsigned short integer data 8-bit, if I used, so I will write it here. Short integer see unsigned short integer data. This also I use US. If I put unsigned data, and here I will define this one MB10. Okay, and this one data also I will use this MB20. He will, and this unsigned integer it using in MB, and this MB data is 0 to, for example, 255 hours memory. Total is 256. When our using the formula, it's coming 255. Then so when that's MB10 and MB20, this out value, and why not he is using this one? Because of that on timer on delay value have to be fixed up to 255. Yani, for example, in you are using in milliseconds, you have to be write 3000 or 1000 minimum. You have to be write this value for on this timer. If less than 1000, you can't use this MB10. You have to be used, must be in unsigned integer 16-bit, or you can use unsigned double integer 32-bit data. After you can write any value or something. See, one more time we will go to the tag table and we will use it here. We will use it here. Unsigned integer, unsigned integer, unsigned integer no sorry signed integer we have to be right. Signed integer SI and sign. See, this one, first one is coming signed integer, and that one also SIN signed integer, and here data is also MB10, and this also you using our MB10 for example. And see, also still he is not writing this MB10 or MB20 because of your value signed. So in signed integer 16-bit data is also using for minus yani 32,768 to plus 32,767 yani. and see after go in the next time to word, word, if you using that word data, and also here using that word data, and what see this will what he say MW20, and this is what using MW10. For example, see this one is MW10 and MW20. Still he is no writing this data because of this value range have different. And when we're using the D word data, see here also you have to go D word data, and have to be define it here MD20, and this one also you have to change this one. It will be automatically use this data when you write it here. This take this iota MD10 and MD20, and now he say that's any value when you like to write in this timer you can write. When you use this timer, must be you have to use this timer. After again you have to be download the PLC. If this values not okay, also this program will be not accept. Can be help in the making program, but this is first time explaining in the signed integer data, unsigned integer data, 16-bit, 32-bit, double integer or integer, and byte 0 to 255 to minus 128 to plus 27. This you can understand about this values. Very long data can be written the program. Now see this value is 3000 store. If we execute this one, after 3 seconds after, it will be on his output, change his output. I hope maybe guys you understand about that memory addressing, how we can use in this PLC programming. This same that this data are when you're using the bit can understand 0 to 1, and when 2 bits using this is 4 bits inside the using r 0 equals will be 0 0, and 0 1 is equals 1, and 1 0 is equals 2, and 3 equals 1 1 equals 3. Means this three digits, and this combinations how coming, this is with this formula 2 to n the power of this 2 bits, 2 to n the powers of 8 bits, 16 bits, 32 bits. Seem like as increasing the bits, many of other datas also have inside the programming. Very long the system, that bool, byte, and signed, unsigned, or word, integer, undint, or d word, dint, real, long integer. Where you have long data, have many more also, but some data I discuss with you, and I hope you little understand about this PLC addressings and data types, how we can use in the PLC. And also in memory bits, if you're using 1 byte and 0 to 7, you have 8 bits in the 1 byte. If you 2 bytes using 100%, you have to be using this MB data, and after next in MD, next in MW, next MDW. This data seem like increasing, and you can use If you not understand anything in this lecture, you can send me the message in comment section. I will give you feedback at the comment. And also if you send me email, I will, as soon as possible, I will send back to a reply. Thanks for watching. Allah Hafiz.